Hi everyone, welcome to my math video. I am Mrs. Xie. Today I would like to introduce one of the irrational numbers in algebra. In my previous video about numbers, there's a diagram to show you how the rational numbers and the irrational numbers differ. Today I am going to introduce you one magic number, e, in algebra. So what's e? E is a transcendental number, meaning that it is not the root of any polynomial with integer coefficients. What's special about e? E is the base of the natural logarithms. In this video, you can learn how to represent e, and what e is used in our life. Let's start. E shows up over and over in mathematics, in algebra, in calculus limit, in derivatives and integrals. In algebra, e is the base number of the natural logarithm function y equals ln x. Its inverse function is the natural exponential function, making them perfectly paired in equations. In calculus, we will use e to represent the limit of an infinite series of powers, perhaps, more interestingly, the derivative of e caret x is itself. This property describes a system that grows at a rate proportional to its current size. In other words, the bigger it gets, the faster it grows. This figure shows how the natural logarithm function grows as x approaches 1, e or infinity, vice versa. You can draw the natural exponential function too. Some series representations of e are e equals 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial and so on. Another way to represent e in series is e equals 1 divided by the sum of 1 minus 1 plus 1 half minus 1 sixth plus 1 24th, and so on. There are many more series involving e. In decimal expansion, e equals 2.71828182844590. You can expand e to over 2 million digits according to some website data. The limit of the nth power of 1 plus 1 over n is equal to e. You will find out the proof by taking natural logarithm on both sides of the equation and by rearranging the expression for L'Hopital's rule. Convert this to a form by 0 over 0. The limit shows nth power of 1 plus 1 over n converges. Although commonly associated with and named after Swiss mathematician Leonhard Euler, it was first discovered in 1683 by mathematician Jacob Bernoulli. He was trying to determine how wealth would grow if interest were compounded more often, instead of on an annual basis. There are many applications use e. For example, the natural exponential number e is used in sound science primarily to define the Neper, NP, a logarithmic unit for ratios of sound pressure or power, often related to decibels. The modeling of population growth and decay are also represented by e to the power of t, modeling continuous, natural processes where change occurs instantly, rather than at discrete intervals. In finance, the Euler's number is used to calculate how wealth can grow due to compound interest. The formula A equals P times e to the power of RT describes how continuous compound interest works on the principal amount P, where P is principal, R is rate, and T is time. Today, we look at the special number e and how it shows up in many places. Perhaps, most interestingly, Euler's equation has integrated this mathematical constant to equation with this neatly. E to the power of I times pi plus 1 equals 0. It is a special case of Euler's formula when x equals pi. There are many links about magic number e on the website. A sampling of these is provided by mathworld.wolfram.com. Have fun to read. Thank you for watching my math video. See you next time.